Okay, we're looking at balancing redox reactions. Now remember there are two main methods, balancing using half reactions and balancing using oxidation numbers. We're going to start with the balancing of oxidation numbers. In order to do this, it's important that you know how to calculate the oxidation numbers of a species in a particular cation or anion that you're given. So you will need to know your rules for calculating oxidation numbers, and I'm not going to go through them in this video, but I will be using the concepts to get the answers that we need. So we're going to start with this formula. We've got a permanganate, the MnO4 minus, plus the iron 2 plus, going to manganese 2 plus and iron 3 plus. So step number 1 is we need to work out the oxidation numbers for each species that has been oxidized or reduced. So for the manganese, we need to work out what the charge is in the permanganate, and that is 7 plus, and on the other side the 2 plus. For the iron, we have the 2 plus and the 3 plus. The next thing we need to do is to determine the change in oxidation number of each. So we've gone from 7 plus to 2 plus. That's a gain of 5 electrons. So this is reducing. The oxidation number went down. And for the iron, we've gone from 2 plus to 3 plus. This is a loss of 1 electron. And we have the oxidation number going up, so it's oxidation. The next thing we need to do is add coefficients to balance the charges, so that we have the total charges being equal on each side. So we do this by cross multiplying. What we want to do is we want to take the change in 1 for the iron, and multiply that into the manganese. Now you don't usually need a 1 there, but I'm just showing you that you do essentially cross multiply that 1. We would then want to take the difference of 5 electrons and cross multiply that into the iron. Alright, then what we've got is the 1 Mn times 5 and the 5 Fe times 1, and they're both equal to 5. The next step then is to actually balance the oxygens by adding water to the side that doesn't have any oxygen. So we've got the MnO4 minus on the left, so we are going to need 4 waters on the right to get the 4 oxygens, so that all of our oxygens are balanced. The next step after that is that we need to add in some H plus to balance the excess hydrogen. When we added the water, we had some hydrogen, so we need to add these in. So we're going to add 8H plus on this side. And we have now balanced our hydrogens. The last thing we need to do is to check to see if the charges are balanced and that we have created a balanced reaction. So we've got 8 plus, 1 minus, and 5 2 pluses, and that's a total of 17. And on the other side, a 2 plus, the 5 3 pluses, and nothing for the water, again 17. So that we know now that this formula is completely balanced. And that's our balanced formula. Okay, we're continuing balancing reactions, this time with half reactions. So the first thing you need to do is determine the half reactions from what you're given. And information like this, what we can do is we can say that the Mn must have turned into the Mn2 plus, and that the iron must have turned to the iron 3 plus. So now we have the 2 half reactions. Step number 2 is to balance all elements other than hydrogen and oxygen. Well, for the Mn's there's 1 on each side, and for the Fe's there's 1 on each side, so they're already balanced, so we don't need to add any coefficients at this stage. Step number 3 is add water to balance any excess oxygens. You can see from the MnO4 minus that there's 4 oxygens on the left, so we'll add some water to the right. We need to add 4 so that our oxygens are balanced. The iron doesn't have any excess oxygens that need balancing, so we don't need to add any water to this one. Step number 4, add any H pluses to balance any extra hydrogens you just added with the water. So for the MnO4 minus equation, we need to put 8H plus on the left side in order for that to balance. Again, the iron is fine. Step number 5, we need to balance the charges by adding electrons. So if we look at the top equation, we have 8 plus, 1 minus, which gives us a total of 7 plus, and on the other side we have 2 plus. So we need to make the 2 plus make the 7 plus into 2 plus. We can do this by adding 5 electrons, and we'll get the 2 plus, and that means that our left side will be equal to our right side. So putting the 5 electrons up into the equation. Now looking at the iron, it's got Fe2 plus on the left side and 3 plus on the right side. And what we want to do is bring the 3 plus down by adding an electron to 2 plus so that these are the same and balanced. And we do this by putting 1 electron onto the ions equation. And now they're balanced for charge. Now what we want to do is actually balance the electrons by multiplying each equation out by the opposite number. So the iron is going to be multiplied by the 5 to bring that 1 electron up to 5 electrons. And now that we've got 5 electrons on each side, all we need to do is add the equations to cancel out any species that appear on both sides. So we've got 5 electrons on the left in the top equation, 5 electrons on the right in the bottom equations. These will cancel out. And then all we need to do is rewrite everything on the same side. So add in the 2 equations and we end up with the exact same equation as we did balancing by oxidation numbers, but this time with half reactions.